Hello and welcome back to IXL tutorials. This is Mr. Duffick and today we are doing IXL M2, which is titled Triangles and Bisectors. So most of these problems are going to look the same, just like IXL M1. And what you're going to see here are a series of triangles, usually two triangles, and a line going through them, specifically a bisector. A bisector is a line that just cuts something in half. The word bisect, bi means two, sec means cut, so cut into two equal pieces is where we get that word from. And so one side of the triangle, specifically the hypotenuse for each triangle, is shared, which is going to be our bisector, and that's going to play a big role in how we solve these problems. So these might not look so easy, but trust me, they are pretty easy actually. So let's do the first one here. If the measure for angle RSU, so right here, is equal to TSU is right here. So it's saying if these two angles are equal over at S, and they are equal to 61, so 61 and 61, and TU, so this length right here is 14, what is RU? So what it's doing is it's giving you all the information to say that these two triangles are basically congruent. They're the same thing. They're equal. So all the measurements here, all the angles, all the sides are going to be the same. And so if our long leg here, TU, is going to be 14, that means our long leg here, RU, is also going to be 14. Okay, and the rest of these problems are not going to differ too much from that. They're going to give you a series of congruent triangles, and you're going to figure out the measurements. So it says, what is the measure for angle GHI? So the entirety of this angle right here at H, right, GHI, it wants to know what this entire thing is. Okay, well, we know this little angle here at JHI or IHJ is 61, and we know GHI is also going to be 61. So both of these little angles are 61. So the entirety of H, or GHI, is going to be 61 plus 61, which is 122. Okay, now it says the line QR, so this slant right here, and RS, this other slant right here, are congruent. Remember that little squiggly on top of the equal sign, or the tilde on top of the equal sign, that just means congruent, which means same or equal. So these two sides are equal. Great. And PQ is 27, therefore what is PS? So if these are equal, they're congruent triangles, blah, blah, blah. You get the idea. So if this one's 27, that means this one is also 27. Okay. This one, what is EF? All right, again, all congruent. So if DE is 71, EF is going to be 71 as well. So I'm going to skip from here. Let's see if they get a little harder. So we jump to this level here. Now it's the same thing, except they give you variables. Surprise, surprise. Okay. So it says RS is equal to RU, so RS, RU. So both these bases right here are congruent. They're the same thing. I can draw a little tick mark here if you like. Okay, and they're going to equal 11, in fact. So 11 and 11. ST is going to equal 8P, so this one's going to equal 8P. And by the way, that would imply these two are congruent, so I can do... In fact, I'll do 3 just to not confuse the 11, I guess. And so that's 8P, and then TU equals P plus 14, so P plus 14. What is the value of P? So like I just said, we know that these two sides are equal or congruent. So we're going to set these two values equal to each other because they equal each other, right? So 8P equals P plus 14. And from here we can solve P. So we'll subtract P from both sides here. P minus P is 0. 8P minus P is 7P, which equals 14. And then we'll divide 7 both sides, and we are left with P equals 2. All right, we'll come back here. We'll go P equals 2, and there we have it. Okay, same deal here. You're just going to set these two sides equal to each other, A plus 44 equals 3a. Next. Next. Same thing. Next. Jumps all the way to 96. Okay, so I will do this last problem for you guys. Looks like it's pretty much the same as everything else. So it looks like RS is equal to ST, so RS is equal to ST, all right. RU is going to equal to Z minus 5, and TU is going to equal 3Z minus 65. What is the value of Z? So we know these two are equal, so we're going to set them equal to each other, just like last time. Like this. Okay, Z minus 5 equals 3Z minus 65. I'm going to subtract the Z from this side over to this side. So we have negative 5 equals 3Z minus Z is 2Z minus 65. And then to get Z by itself, I'm going to add 65 both sides. So that's 60 equals 2Z. All right, and then we're going to divide both sides by 2. So we are left with 30 equals Z. All right, so that's our answer. Z is 30. So we'll go back, type in 30, and there we have it. Okay, that's where I'm going to end the video. Stay safe, study hard, and I'll catch you for the next IXL tutorial. Goodbye.